Hi there. So today we're going to be talking about rational numbers. Rational numbers may have been something you talked about last year, and we use rational numbers to classify certain types of numbers. If you remember classifications, they're different. We have lots of numbers and we can classify them lots of different ways, which we're going to talk some more about later in this chapter. But for today, we're just going to concentrate on the rational numbers. So the definition of a rational number is this. A rational number can be written as the ratio of two integers in which the denominator is not 0. And so that would be something like, you're going to see the ratio written as A over B, right? Remember, there are 3 ways to write ratio, but the most common way to write a ratio is as a fraction. So we're saying any number that can be written as a fraction of two integers, so they have to be like whole numbers. They have to be like 2 over 3 or 7 over 9 or something like that, all right? They can't be 0.3 over 2.6 or something like that, all right? So you want them to be integers, whole numbers. Integers means they could still be, if you have a negative, that would be okay. Okay, that's still considered a rational number. All right, so any number that can be written as a ratio, A over B, where the denominator, okay, this bottom part down here, is not a 0, is what makes a rational number. All right, so numbers like 4, like if you have a whole number 4, okay, that's a whole number, but it's also a rational number because I can write 4 as a fraction, right? If I make 4 into a fraction, I write it as 4 over 1. Well, are those two integers? Yes, and the bottom's not 0, so then that also is a rational number. So the rational numbers make up a ton of numbers because almost any number can be written as a fraction, all right? And we're going to talk more about that later in the chapter. There are a few that can't be written as rational. We're going to talk about those as well. All right, so another way to identify rational numbers is to know that every rational number can be expressed not just as a fraction, but as a decimal. And if you watched the last video, the way you can change a fraction to a decimal or a ratio to a decimal is by using TIBO, okay, which again stands for top in, bottom out. All right, if you didn't see that last video, then I'll show it to you in just a minute. Okay, so the decimal form of a rational number will always be, so you're going to get two things when you divide a fraction. You're either going to get a terminating decimal, okay? And when I say terminate, what does that mean? I mean, like a lot of people say, well, like when you kill somebody, that's termination, okay? Or if you terminate somebody's job, that means you stop their job, you fire them, it ends, all right? So terminating decimal is a decimal that ends, all right? So that would be something like 0.4, that's it, okay? It stops, it's 0.4, okay? Or it could be 2.394, okay? But again, it stops, it doesn't keep going. It could be negative 2.394, right? These are decimals that stop. All right. Or you're either going to get one of those or you're going to get a repeating decimal. Okay, and a repeating decimal would be something, and you've seen these before, like 0.66666. Okay, so when you put the line over it, that's a repeating decimal. You may see it written like 2.3535 ... Okay, so you can obviously see that that's going to repeat. So this would also be an example of a repeating decimal. Okay, notice, or just as a reminder, if 2 digits repeat, then the way to write that is to put the line over both of the digits, okay? All right, determine whether the following decimals are either terminating or repeating. All right, so we want to change these to decimals. We use that. I told you I would tell you about TIBO. That's where we're going to use it, by using TIBO. So TIBO means top in, bottom out. That's just a way to set up division because we're going fraction to decimal. If you're looking at your chart, FDP, right, fraction to decimal, you're doing this part right here, which is divide. All right, so the top number goes in, the bottom number goes out, and then we're going to divide. Can't divide 8 into 5. Add your decimal and a 0, and 8 will go into 50, and I'll go 6 times. So 6 times 8 is 48. When I subtract, I'm going to get 2. And add another 0, bring it down. 8 will go into 20. 2 times. 2 times 8 is 16. I'm going to subtract that and get 4. So I'm going to bring down one more 0 because if I have a decimal that continues going, then I have to go at least 3 decimal places before I can stop, before I say it's okay to stop. So 8 will go into 45 times. And then this one does. Actually, I don't have to add another 0, so this becomes 0.625. Okay, and then I'm supposed to determine, is it terminating or repeating? Well, because I didn't get a remainder, right, there's nothing I need to keep. I don't have to keep bringing something down. So this decimal, even though it went 3 places, it did stop at 3 places. So this is a terminating decimal because it stops. Okay, I like it when you box your answers, so do that for me. All right, -1 and 2/3. So again, this time I have a mixed number, so that's going to be in front of my decimal, just like -1 is in front of my fraction. So the 2/3 part is the part I have to change to a decimal. That's the part that I'm going to use in my division. So the top number is 2, the bottom number is 3. So top goes in, bottom goes out. 3 won't go into 2. Add your decimal, bring it up, add your 0. 3 will go into 20 6 times. 6 times 3 is 18. When I subtract, I get 2. Right? If I bring down another 0, 3 will go into 20 6 times. 6 times 3 is 18. When I subtract, I'm going to get 2 again, right? And so if I bring down one more 0, because I always go 3 places, 3 will go into 20 6 times. And you may have already guessed that this was going to keep repeating, but like we like you to always do 3 digits just to make sure. So 0.666. So this is going to be a repeating decimal. So when I write it over here, because I have to put it back over here with the -1, then I can put a line over the 6 to show that this is repeating. And obviously, this would be a repeating decimal. Okay, and I can be sure of that because I kept getting the same remainder each time, or the same number when I subtracted each time. All right, if I look at 4 and 1/11, so first thing I'm going to do is write the 4 over here so I don't forget about it. And then I'm going to divide the 1/11. So the top number is 1, it goes inside, the bottom number is 11, so it goes outside, top in, bottom out. Oh, bottom out, not 10, 11. Okay, so I'm dividing 11 into 1. So I can't divide 11 into 1, add a decimal, bring it up, add a 0. 11 won't go into 10 either, so make sure you put a 0 above, because I was dividing into 10, so I have to have a number above that 0 over that 10, right? And then you can add, or you can go ahead and subtract it. 0 times 11 is 0, so when I subtract, I get 10. Bring down the next 0. 11 will go into 100, so now I can divide 11 into 100. It'll go 9 times. 9 times 11 is 99. And then when I subtract, I'm going to get 1. All right. And so I'm going to bring down another 0. 11 won't go into 10. So what do? Well, a lot of times you would say, just bring down another 0. And you are going to bring down another 0. Before you bring down another 0, you have to put something here. Right? So 11 went into 10 how many times? 0 times. So you have to put a 0 here before you can bring down the next 0. Now, is this number, remember, we're trying to decide, is it terminating or repeating? It might be repeating, right? Because it's 0.0, it started with a 0, and then it changed to 9, and then it went back to 0. So I'm going to do one more. Even though I tell you to do 3, I'm going to do one more just to be sure. See if this is a 9, then I can say that this digit, this number is repeating 0909. So if I bring down one more 0, I'm going to go 11 into 100. That'll go 9 times. 9 times 11 is 99. And sure enough, right, this is going to be 1 again. So what's going to happen? I'm going to bring down another 0 and try to divide 11 into 10. So that's going to get a 0. Okay, so this is repeating. So this is 4.09, and I'm going to put the line over both of my numbers, right? Because we talked about this earlier. If you have 2 digits repeating, you have to put it over both of the digits. I didn't put it over the 4. The 4 is not repeating. All right, and then again, we've already said that this is a repeating decimal. All right, so this last section, we're just going to determine whether the following numbers are rational. All right, so based on what we were told at the beginning, rational numbers can be written as fractions, They can be written as terminating and repeating decimals. So that's what you're going to look for in this. So 3 is not a fraction. Okay, it doesn't have a decimal, but could we make it a decimal? Could we say that this is the same thing as 3.0? Yes. Okay, so is that a terminating decimal? Yes, it is. All right, so this is rational. So determine whether or not, so we're going to put yes, rational. All right, how about this one? 3.1671295 ... All right, well, it's obvious these numbers aren't repeating, and then the ... tells me it's not stopping. So is this rational is this rational or not? Well, I would say nope, it's not rational, okay? Because I don't have a fraction, I don't have a terminating decimal, and I don't have a repeating decimal. All right, look at -4. What do you think? It's kind of like what we did with the 3 before. This isn't a fraction. We could make it a fraction. We could write it over 1. It doesn't have a decimal, but we could make it 0.0, and then would it be terminating? Or even repeating? You could say it would repeat the 0 over and over and over. Okay, so we will say yes, this is a rational number. And if you remember from last year, the rational numbers include most numbers. So it includes all your integers, all your whole numbers, all your counting numbers. All right, 7 is 25.121212 ... Okay, so this obviously doesn't stop. It's not terminating, but is it repeating? Yeah, okay, it's repeating the 121212. So this is a repeating decimal, which means yes, it's rational. All right, look at -2.687. It's not repeating, but does it stop? Yes, there's no ... So this is a terminating decimal. If it's a terminating decimal, then it is rational. All right, and then 4 1/2. Okay, so fractions, are fractions rational? Yes. Can they be changed to decimals? Yes, but that's not what we're being asked to do this time. We're just asked if it's rational or not. Okay, so anytime you have a fraction, it's definitely a rational number. All right, the rational numbers, they're a comparison, a ratio, where a and b are integers, okay, and b is not equal to 0, right? 2 ways to write rational numbers, fractions, and decimals. But if you write it as a decimal, it's either going to be terminating or repeating. All right, see you soon.